everyone, we're back. It's Charlotte and Jenny from the Bursary Foundation, continuing with
Hi.
our social distancing 11 plus masterclasses. So today we're going to be having a look at a bit of verbal reasoning, and the focus for today is sequences. So sequence is one of those words where people look at it and go, oh no, that's big and scary, and I'm pretty sure that's some kind of crazy maths thing. I don't like it. Does that sound about right to you, Jenny?
Pretty much, yeah.
Yeah. It's not actually that bad. So here's a very good secret for you. We actually use sequences literally all the time. One of the first things you would have learned in school in Key Stage 1 is your times tables. That's just a sequence. We even use them in art a lot. For instance, the black, white in this flower. That's just a sequence that happens to be using colour. Okay, so sequences are really just all about spotting and identifying patterns in terms of lots of different things. Maybe it's a word, maybe it's letters, the alphabet, all of those sorts of things. This is something that's also really good to practice because it might come up in your maths exams as well as verbal reasoning, because we get number sequences like with our times tables here. So, we ready to jump in?
Yeah, let's go for it.
All right. So, number one, here's some numerical sequences for you. So, what we need to think about here is what's the pattern that's getting us between each of these different numbers so we can then fill out the next two over here. So, what I'd be doing is looking at what sum could I have done to get from 5 to 7, from 7 to 10, from 10 to 14. Oh gosh, these arrows are terrible, and so on and so on. So what do you think,
Okay.
Jenny? What sum did we
So
do?
5 to 7, we're adding 2.
Mm-hmm.
7 to 10, we're adding 3. So maybe there's a pattern emerging.
Yeah.
10 to 14, we're adding 4. Yeah.
Okay.
So adding 5.
So we can then easily say, well, if we add 5 to get from 4 to 19, to get to the
Yeah.
next number, we've done,
Let's add 6.
yeah, because we've done 2, 3, 4, 5, 6. Makes sense, doesn't it? So here, the pattern itself and the sequence itself is actually its own pattern and sequence. So do a plus
It doesn't
6.
have to be the same thing happening all the way through the sequence.
Yeah, exactly. So if I do 19 plus 6, then that's going to get us 25.
Yeah.
And then I'll let you lot work out the last one by yourselves. Yeah. Okay. So have a go based on that and see if you can work out how to do B. Maybe you can pause the video and have a go at that for a second. Okay, let's unpause at this point then. So with this one, what I've done is I've halved 168, subtracted 4, and then I can see half of 80 is 40. I've subtracted another 4 there, so we're going to keep doing the same pattern again and again. If, for instance, you were struggling a little bit with 168 and 84, you could completely ignore those and just skip straight to 80 and 40, because those are really common halves that we know that we can work with. Pause the video for a moment, see if you can work this one out. And let's presume you've unpaused there. So, we've got a bit of a funny one here. 5, 6, 10, 12, 15. Going between each number, there's not really any obvious pattern because I've got a plus 1, plus 4, plus 2, plus 3. It's all a bit weird. So what I might do at that point is look at every other number. So, Jenny, if I have a look at every other number going 5, 10, 15, can you tell me anything about them?
It's the 5 times table, isn't it?
Yeah, so if I skip the first blank and go straight to the second one, what's that going to be?
20.
Okay. All right, so that's worked out really well. So let's try looking at the other numbers. So I've got 6, 12, and then what could we have?
Well, my question would be, it could be one of two things, really, couldn't it? It could be we're doubling it, or it could be just adding 6.
Possibly. So maybe there's something we can do to work this out then if we think about a second sequence. So what have we done to get from 5 to 6?
+1.
What did we do to get from 10 to 12?
+2.
So what would it make sense that we do to get from 15 to the blank number?
+3.
That's likely to...
okay.
And if we look at that and we do 15 plus 3 is 18, we can test and prove that this works because 6, 12, 18 is the 6 times table.
Okay.
All right. So we can see then that this sequence actually works really, really well here in a couple of different ways. And you might find that for a few of these sequences, there are different ways of solving them and different ways of spotting the pattern between numbers. So long as you get the right answer, that's the main thing. Okay.